There we
It's
go.
about
There,
to
red,
start.
something red indicated at one time. Okay, there's the
Oh,
okay.
okay, we're on.
Okay, Jerry and Chuck and Tim and doggone everybody, welcome aboard. Here we go, the SBAU Astro Hour. It's a weekly Monday morning online get together and Zoom, a big blog for Santa Barbara's astronomical unit. And I'm your host, Ronnie Herron, the guy on the SBAU board who does not have the answers. Therefore, they have me on here as MC. Somebody's going to ask the questions, I guess. I'll introduce the rest of our brain trust, the board. What's on board with us here today? A little shorthanded. We're on YouTube, and our website is sbau.org. Go online, read all about us. We're based at the Santa Barbara Museum of Natural History. And I got to tell you, please join us. Start with a meeting first Friday of the month, be Friday, March 7th. Our speaker, Dr. Bennett, will cover Beyond UFOs. What are we talking about? Well, let's see here. Full moon about an hour before dawn, but we got plenty to look at Saturday night at our star party. Speaking of the moon, there's a canyon deeper than the Grand Canyon on there. We're going to talk about that. Here's one to watch in the early morning hours with binoculars, M11, aka NGC 6705, the dreaded wild duck cluster. It's in Scutum, which sounds to me like a medical term. I wonder where the scutum is on that. Never mind. The parade of planets continues. And speaking of clusters, did you know the Pleiades are plowing through space at about 4 miles a second? Going to nail down locations, names, and magnitudes of what you're looking at in the nighttime sky this hour, including a fast creeping red dwarf star. Speaking of coming at us, wait till you see what the brightest star is going at and where it's headed in a minute, and the sillies we'll see. And what Perseverance found on Mars, everybody. Here's breaking news. About a 200-foot across diameter NEO, that's near Earth object. It's asteroid 2024 YR. I don't know if that's short for year or just YR4. The odds are increasing a little bit. It may hit the Earth in about 7 years.
It's
First
only like
round.
50 feet across, Ron.
What?
It's only like 50 feet across is the estimate.
I got 197. And so I just rounded it off to two. And that's from Jerry's talking points.
Yeah, I
And
got it from space.com. Their early estimates, they can get corrected all the time.
Yeah.
okay, well, you also mentioned somebody named Rankin, but we didn't get the opening part. Are you cut out
No, I was still editing that and time ran out,
editing
so
out
I
somebody
just said
named
it.
Rankin? You're going to have to tell us that. Jerry is our president, 7 or 8 years. How are you?
Good.
Still healthy? Okay. Don't disappear on us. He's the commander of this. Pat Forgy is his lovely wife. I get to see her at meetings sitting at his side. Chuck McPartland and his Pat. Between him, he's our outreach coordinator. She holds down two posts, merchandise and treasurer. Between them, they cover three areas in our club. Here's Tim Crawford, resident lens expert. And Tim awaits the arrival. He's married to Karen, but we're awaiting Bruce. Do I ever see your wife at these events? Some of them you don't even make, do you, Tim? You're on screen like
That's right. Sometimes for the meetings I come on the screen now and then, but no, I haven't been on the Friday ones for a while. But no, my wife, she's hard to get out there.
she is.
Yeah,
Well, Bruce Murdoch is not with us yet. He may log in. His wife had a bad fall and broke some bones, and she's recovering. So I see him alone. If I can see you at the star party where it's down to the 50s and we're all chilled and bundled up, I should be able to see you among all those folks we love to mingle with at
yeah,
Fleischman Auditorium.
yeah.
Of course, you've seen a number of planetarium shows. Anyway, let's do the sillies. President Jerry always forwards us a bunch of silly science cartoons, and these are good. There's about half a dozen we'll get to, some thought provokers included. So here we go. This is alien graffiti. If extraterrestrial wanted to leave his mark, he'd say, Earth, you're boring. I'm sorry. Why not go live somewhere else? I've seen things like that, and I wonder, okay, here, I love this one.
Yeah,
Anti-pun.
this
They're sitting at a restaurant. He says to her, You know, I come here just for the halibut. To which she replies, Oh my God, don't talk so loud. I have a haddock. And he goes, Sorry, I thought you were hard of herring. I think they carp too much to each other. I really do. Okay, these are good. Last minute, then overnight. Let's do another one.
Well, it says after down at the bottom, it says after a few more minutes of this, Brad and Judy agreed that they should join an anti-pun support grouper.
Oh, I didn't even
I missed the last word. I missed that last word.
Grouper. Okay, I didn't even see that at the bottom. I'm sorry. I was just doing. Thank you, Jared, for that.
Is it not visible?
It is.
I'm sorry.
Okay.
It may not have been visible to me, maybe I'm just stupid enough.
Okay.
This one might need a little explanation, but I figured it out after a while. Speeds of different things, a vast range of RPMs for different functions, from the slowest, say, snail speed or telescope tracking, to a spinning neutron star, or in this case, a dental drill. I can see how that goes from the slowest at the top to the fastest at the bottom, right? In
Yeah.
RPMs on the left.
That's quite a range for a handheld tool.
Yeah.
I'll bet. We'll call it the tachometer tech. Did you know, ladies and gentlemen, here's what I mentioned a moment ago. Sirius, the dog star, is moving closer to Earth at a rate of about 9 miles per second. This means someday we could be in serious trouble. You know what I'll probably take out first is XM Sirius's satellite when it comes. Okay, a priest, a pastor, and a rabbit walked into a blood donation clinic, and the nurse nursed. That's not supposed to be a past tense nurse. Asked the rabbit, "What's your blood type?" Well, he says, "I'm probably a type O or a typo."
Yeah. It took me a while for that one.
Yeah, me too. That sounds like a Tom Whittemoreism. He's not available with us.
Yeah, I put on these puns because of Tom, and then he told me later he wasn't going to make it to today's show. So,
well, can I tell you a quickie that cracked up a couple people last night? This I read, believe it or not, in December's Reader's Digest. The 3 guys die, go to heaven, and there's St. Peter at the gate, letting him through, but he stops him and says, "Show me something in your pockets, gentlemen, that represent Christmas." Because this was the December issue. One guy says, "Okay, I've got my Bic lighter here. That kind of represents the candles, the candlelight on the tree. Okay, you're in." Next guy, believe it or not, this joke is going to be borderline, but it was in Reader's Digest. The next guy took out his car keys, says, "These represent jingle bells." Good, go on in. The other guy took out a pair of female underwear. And St. Peter says, "What the heck is that?" And he says, "Oh, these are carols."
oh,
God. Oh boy.
And I hope she wants them back. Never mind, shut up. Okay, we're going into space, and that's not exactly a space picture, but it's a darn good diagram. Oh, is this the terrible incoming? It's either
I'm
200
not sure that the article was very poorly written that I read. There's not a lot on the web yet about this, but this is 2024. This diagram may not represent exactly 2024. It represents the uncertainty of orbits in general, where you only have a limited period down in this region. Let's see, where near Earth. So this region, say, of a few months worth of observation, and the recently discovered near-Earth object is actually moving away from us, so it's heading on out. But the uncertainty in our measurements in here give a very big spread in the apogee, so that we need and other observations farther along in this region up here to pin it down.
Jerry, there's an interactive orbit diagram for YR4 at spaceweather.com.
Okay. Can you share it?
Oh, yeah, let me bring it up.
Gentlemen, wasn't there a name, had a Grecian name on an asteroid that was dangerous? Sounded like Pathos or Bathos.
Apophis. It's an Egyptian god.
Yeah.
Is that a separate? Is that another one?
That's another one.
That's not this one we're talking about.
No, this is a newly discovered one in the last few weeks or something. They'd start talking about it.
Apophis.
No,
okay.
This is YR4, not Apophis.
Yeah. I know, but what's the deal on Apophis?
Yeah, I didn't know
Apophis
this.
is not going to come close.
Yeah,
Oh, it's not. Oh, okay.
not that close. But it's going to fly
Right.
under our communication satellites.
Okay.
You're taking over the screen there, Mr. Outreach.
Yeah,
Yeah.
here's the small body, the JPL small bodies, um, where you can get ephemeris and ephemerides and things like that. So
Yeah.
here's the,
This looks like it's essentially the same diagram.
yes,
Yeah.
except it doesn't show it whipping by Venus but it's a very similar diagram.
Yeah.
So you can see YR4 orbits within Jupiter's orbit, and its position right now is right there above the Earth in the diagram.
Huh. And this sucker is from the belt.
No,
Well,
this is a near Earth or it's got an elliptical orbit.
yeah.
Oh, but it doesn't come from beyond Mars where the asteroid belt is.
Yes, it does. You can
It
see
does go
Mars
out
is
there,
here.
but it also comes in. It was probably happily out there when something perturbed it, and that's
Yeah.
why it still
If it
has
were in
that
the asteroid belt, it would be going around here.
around out here, probably is what you mean.
Yeah.
Yeah. We couldn't see what you were pointing to, Jerry.
Oh, I'm sorry.
Yeah.
Oh, you
What
can't
is
see my
the period
cursor?
of this? Is
Oh,
this
that's right. You're the one sharing it.
Yeah. Yeah.
is this like a year, Chuck? The period?
No, I think it's 2 years.
Okay.
Let's see. We have 3.99 years, so 4 years.
Okay.
Okay.
And
Do
they
you have the diameter anywhere on this chart?
the 2.5 AU, that kind of thing, the semi-major axis. Oh, the diameter of the
No, the
asteroid.
diameter of the object. Yeah.
I'm not seeing it. Well, the
Because
last I
you
saw
said
it
you
was,
read it was 50 and I read it was 200.
yeah, last I saw on the occultation list, it was estimated at 50 feet.
And
Okay.
So comparable to the Chelyabinsk impactor.
Yes.
And there have been a couple of there was at least one occultation possibility for it that somebody was going to set up and try, but they figured out this asteroid is so small and moving so fast that they would have so many problems with, especially because of the size, they would have problems with diffraction, that it would be hard to tell exactly where the start and stop of the occultation were.
I'm getting here on this is probably an AI thing, but it says that it measures about 40 to 90 meters wide.
Yeah, I think they've scaled it down, but
Okay.
Yeah,
40 to 90, that makes it over 200 feet.
it looks like just a dot, so no one is actually resolving the distance, the diameter of it.
this is all estimated on its reflectivity.
Right.
And they'll get a better value if they can get an infrared scope on it.
Well, can I read you what it said in the New York Times yesterday, to the 9th? The odds of an asteroid striking Earth in 2032 keep going up and down. Apparently, the biggest odds are not 1 in 83 anymore of us hitting us. It's 1 in 43, which down to 2 or 3% range, I believe you had, Jerry.
Yeah.
No, that's right.
And you mentioned somebody named Rankin. Is that a professor or scientist who discovered this?
He wrote the article in space.com that I was looking at.
Okay.
Okay.
And it's called 2024 YR. Does YR stand for year? YR4?
No.
YR, Ron, with asteroids, just like with comets, you have the year it was discovered. Then you have a letter that represents the week within the year when it was discovered. And then a letter that's sort of a sequence number in that. And then the 4 is how many times you've gone through your sequence. So
the YR isn't short for year. Each of those.
No, it's just a
letters
coincidence.
it's telling you that it was found near the end of the year, though.
Okay. Well, I wonder if they're taking bets and odds in Vegas.
Probably.
Oh, yes, I guarantee you.
You think so?
I've got some candidates that I would vote for targets for it, but
Is that right? Well,
The
we
trouble
may be
is
able
it's
to
an unguided object.
yeah.
Some of us may not be here to welcome that in 7 years.
Nah, be optimistic.
Well,
So
what is,
this is the full moon this
oh, a
week
moon?
is the full moon. This is a nice picture of a full moon in a snowy scene, reflecting that this is the full snow moon.
Not for us.
So, but we're going to have that this week. Yeah.
I saw lots of
Now you
shadows of
also
people.
have this is today at 6 p.m. and we still have the parade of planets in here lining up in the sky. If I can find them all, there's Saturn, Venus,
Neptune just below Venus.
oh yeah, Neptune. Good, I was looking for that.
Yeah.
Uranus, Mars, and Jupiter. So they're roughly in a line across the sky.
And where is Mercury?
And you can see this at about, what's that?
Where Mercury's missing,
Mercury's not in it until later this month.
and it'll join the other six.
Right.
Yeah.
And Saturn sets very quickly after this. It's very close to the western horizon and setting.
And Mercury will be also, so it's going to be tough.
Yeah.
Were they watching
Now,
Chuck? Were they watching Saturn Saturday night at our star party?
It set pretty quickly. I don't know if anybody managed to get on it, but they might have.
What was our observatory, Palmer Observatory, locked on?
I have no idea.
I think it was Orion Belt or the Orion Nebula.
Might have been doing the nebula, yeah.
yeah, the nebula is very dramatic.
Okay, so in the middle of all that are planets.
Yes. So this shows in the early morning sky, the M11 is really a summer constellation in the evening, but at 5 a.m., it's
way low.
Right there. This is the center of our Milky Way down here in Sagittarius. This is, in the summer, this will stand upright, and Scutum will be up from Sagittarius. It's a small constellation. It has one red line across it, not very imaginative. And this is where that is, the M11. It's a nice cluster. And the reason we look at clusters around the full moon is they're easier to see. The faint fuzzies are very difficult to see. So we focus on it. This is a nice object to look at.
I don't quite understand what you just said. It's easier to see them with a full moon?
No,
because
you don't want to spend time looking for clouds of dust and gas like nebula, also known as faint fuzzies, because the full moon scatters so much light in the night sky that it washes those things out. And so M11 is a star cluster. It's an open star cluster, and it is easier to see star clusters and star colors. And that's what we're going to look at most of tonight.
Aren't star clusters sometimes fuzzy? They're just if they're big balls of.
Only if you can't resolve them, they become sort of a faint fuzzy. A lot of these star clusters were faint. They look to the naked eye and to small early telescopes. They looked like little batches of fuzzy light. But once the telescopes got bigger and better, they resolved into clusters of stars. And it was thought for a while that every faint fuzzy would resolve into a star cluster, but that didn't turn out to be true.
And
but we're not up to. Go ahead.
I'm going to jump in for Tom Whittemore here, since he's of Polish heritage. Scutum, the constellation there, was originally Scutum Sobiescanum, the Sobieski shield.
Huh.
Okay. Scutum sounds a lot like something else my doctors talked to me about. Are we up to wild duck and Pleiades clusters yet, or is that still to come?
The wild ducks
Pleiades
is
is yet to come.
Okay. What did you say, Chuck?
M11 is the wild ducks.
Right there.
Oh, that's what we're on now. Okay.
Yeah.
This is a finder chart.
Okay. Named because it looks like a bunch of wild ducks?
It does. That's the claim. I've never been able to spot that. It's supposed to look like a V shape of, birds flying south. But the problem with telescopic observation of these is that at different powers with different scopes, it shows different
That's
depth
it.
star
That's exactly
magnitudes.
right.
And you get things that in a little scope are obvious patterns. They could completely disappear in the background of stars in a larger scope.
I think with a lower power, I think M11 might show up as a V or as a kind of a little triangular shape in the sky. I got in trouble for saying it was a V in the sky one night to one customer. So there's no V there.
We do get some argument of customers sometimes.
Yeah, but the M11 it's being mostly a summer object. It's really beautiful if you find it with the right eyepiece and on the right night. It's pretty nice.
And that name for the wild ducks comes from Admiral Smythe or somebody, a British guy who wrote about astronomy in the 1800s.
Well, Saturday night, some of the people at the star party were telling me about another bird they were looking at, the owl.
Yeah,
Owl cluster.
Yeah.
Out apparently with a big full moon up there, almost full.
It's really there's a trick to that. I tried the owl cluster for a little bit, and if you use a lower power, the moon just washes it out. So when you raise the power a little bit, of course it becomes larger in your eyepiece until finally, if you get the right eyepiece, it kind of darkens the background, and you can see those stars that make the asterism that make it that look like the owl. But real careful.
When the sky is luminous.
Apparently, there's a problem with nebulae when the full moon, except for Orion.
Well, not according to one of my customers.
They were looking at the Orion Nebula Saturday night with
but it's going to be really faded out with the full moon.
Yeah, really? one of my customers that night just said, why would I want to look at this? And and Dave was right there. David was right there with his Sea Star, and he goes, "Oh, this is now. Why would I bother with that scope when I could have this?" And it was really fabulous. But we had three people lined up. One guy with binoculars, myself with an 8-inch, and then David with his Sea Star, and we were all trained on M42 with the Orion. And it gave people a contrast. They could see different views of it. It was really nice. It was fun. Really a lot of fun.
And but the
moon will just bleach out everything. It really does.
Did it hit full this morning before dawn?
Something like that.
Yeah.
Okay. I think I read his.
I think it was 3 days away on Saturday. So
this isn't the moon, is it? We're looking. No, these are asteroids.
Yes, this is asteroids arranged in size. They're not flying in this pattern.
I think the one that Jerry's talking about is that Eunomia.
Yeah, Eunomia right down there.
Eunomia
is believed to be the core of a larger body that got slammed a lot, and this is the hardest part that didn't break up.
Oh.
So it's a very heavy object. It's 15. The number is the order in which they were discovered. The first one was Ceres, which was believed to be a planet. So Ceres was the first planet to be demoted to a dwarf planet.
Well, along with Pallas and Juno and Vesta.
Yeah, right there. So now that we have better looks at them, Ceres is the only one that is actually spherical, roughly spherical. Well, Hygeia looks spherical too in this. So
is it about the size of Pluto?
No.
Oh, is Pluto bigger?
This is 100 kilometers there. This is about 600 miles in diameter, or 600 kilometers. I forget which it is.
I think it's 600 miles, and Pluto's 1,400.
Yeah.
Oh, twice. Okay.
Now Ceres has this really bright spot on it, which we sent a spacecraft out there that flew over it and zoomed in. It's got really good pictures of it.
This is, Jerry, just to warn you, this is really washed out, so that's not showing.
Oh, sorry.
Yeah, it's not showing. Yeah, exactly.
Do you have a way of correcting that?
Yeah, he's doing it right now.
That function on my computer died a long time ago. It just stays bright on my screen. I can't dim it at all, assuming that's what it is.
There we go.
Oh yeah, there you go. Okay.
That's a
better.
white spot in a crater called Akator.
Yeah. And it's basically an ice volcano. Ceres is believed to be have a lot of water underneath of it.
Ooh, well, it might be worth landing there. They're
Well,
headed to the moons, I think.
not a
because,
vacation spot for me, no.
well,
But
I'm
we're
amazed.
talking about eunomia is the object for tonight. And we have one of Chuck's favorite diagrams to show where it is. So this is Taurus, Auriga, and several galaxies, star clusters down here. And I have some interesting pictures of those, not that I took, but this is February. Where are we now? We're at 10 right there. So this is roughly where it is, heading this way.
Good luck
And
finding it with that chart, though.
Yeah, it's granted. But I can't, it's difficult for me to redraw this line on a better chart. So I just use these.
Did we miss
Here's
it
the better chart.
in the pictures you lined up earlier, right before this? Was it one of those?
Yes, it was number 15 down there.
Oh, I was just looking at series. Which one is
Right there.
eunomia? Oh, okay. Another potato in space.
Yes.
And they have what's called a shape model for it. And is it okay if I do a share?
Yeah, please.
This was an occultation in 2023 in May of it. Why am I not seeing that? Let's see here. So 4 people took shots at it. It looks like one was a total miss somewhere. I'm not seeing his. You can see how the occultation was fit to the shape model to try to get a rough orientation of how the asteroid was facing us or how it rotates.
Wow. Wow.
So when you do these shape models, they're based on how the light reflects off the object, and you can then make a faceted model that will reproduce that, but it's often ambiguous. And so they often rely on occultations to choose which shape is the right one.
Huh.
But actually, eunomia is big enough that there are some actual images of it from things like the Very Large Telescope. So in this case, it wasn't all that useful, but
Well, does science know at what range of diameter do objects start to be spherical? 300, 400?
it depends what they're made out of, Ron.
So you could have big, heavy ones that are lumpy and
Yeah.
small ones that are solid but totally spherical.
Yeah.
Smaller in size.
Yeah.
Interesting. And little Mercury, our first planet, is smaller than a lot of these things, isn't it? Smaller than
No,
some of the moons?
no. It's smaller than Ganymede. It's smaller than Titan, but that's it.
Okay, and yet it's a planet and there are moons.
Well, it orbits the sun.
Okay. Can you hear me or am I blanking out again?
We got you.
Okay.
You're listening.
This is a more useful chart of where it is. This is the place where eunomia is right now. Oops. Up in here. This is the full moon, and this is at 8 o'clock tonight.
In Taurus, huh?
Yeah.
Well, it crosses the field of stars. You'd think it would occult something sooner or later, wouldn't you? Are the odds that low?
That's what Chuck just showed you.
Yeah,
Is
that
it
was the
occulting?
diagram I just showed you, Ron.
What was it occulting? I missed that.
It was occulting a star.
Oh, but
Those lines going from upper left to lower right, that was a star.
Well,
That eunomia
no, those were the observers
missed that.
projecting into the
Sorry.
sky based on their
Right.
location.
Yes. But
And they know what's coming. Okay.
but the line represented the path of a star with respect to the asteroid.
Of the observer, yes.
Yes.
Hmm.
Now, in this area, whoops, there's a number of interesting. Have I got this, or did this do a trick on me for out of order? No, this is good. Oh, yes. On this one, the cursor represents not eunomia, excuse me. It represents NGC 1746. And in the previous slide here, you see 1746 is near the path of eunomia. So eunomia is passing through this region where there's interesting objects, NGC 1802 and 1746. And they're interesting in their own right and a little confusing too. 1746 is right here. And this is what NGC 1746, 1750, and 1758 all look like. But they don't look to me like separate objects. But they are, because distance measurements, these are associations. I think one is an association, an asterisk. And the other two are about, this is the way they're labeled. So 1758 is this cluster here. 1746 is
the great
here,
one.
and yeah, and and I find this a very confusing way to label these things.
Yeah.
I expect to see a separate object for each name, not things that are blurred and running over each other, but nature didn't line things up that way. So this is what we have to deal with.
Did I miss it? The circles, what do they represent?
Clusters.
Oh, really? They're overlying. There's a dinky cluster inside a middle
So
size.
these star clusters are at different distances.
Oh,
The circles represent different objects. There's three different objects here.
Freezing out on me, Jerry. I don't know if that happened to the others, but yeah.
Yeah, I missed his voice. And the gold stars, I'm wondering if that is associated with the second diameter.
Yeah, but there's plenty outside too, so it's hard to say.
Yeah.
but they overlap each other.
I'll just show the pictures and you guys do the talking.
No, you're the commander, man. We need you.
Not if I'm cutting out.
Now
this is a beautiful shot of the Pleiades.
Yeah.
Oh, and now we learn what's happening with it. It's coming this way. Oh no!
No, not so much.
Well, 4 miles a second, but it's not heading toward. That's Sirius.
Yeah, it's 444 light years from Earth. It's a young cluster between 75 and 150 million years old, so it's got rid of its nebulosity. Even though you see nebulosity here, that's just stuff that's passing through, but that's not the nebulosity that the stars were made from. This topic is binary stars in the Pleiades.
But there's more than 7, right? There's a whole bunch more that we don't see.
Like 1,500.
Oh,
yeah, but in this picture, there's 9. And you might wonder why 9 stars is called the 7 sisters. Well, this one is Atlas and Pleione, I think. That's mom and dad. And these are the 7 sisters.
Oh, got it.
There's 9 bright stars here.
Are they just the largest stars in the cluster? Or are they the closest?
They're the brightest.
The brightest.
Yeah.
Now,
so
now, how do you say that the reflection nebula, is that pronounced Merope or Merope?
I think it's Merope.
Merope, okay.
But that's the star. That's the nebula around one of the stars. It's just the most prominent one.
Oh,
one of the stars is called Merope. That's one of the sisters.
Oh, so the reflection nebula is associated with that star.
The brightest of those reflection nebulae is, yes.
Okay.
Is this chart washed out?
No, it's pretty good.
It's pretty good.
Okay. these are the stars of the Pleiades that are double, binary or just double. So I think we have a chart coming up that shows which ones they are. Yes. So this is the way they're labeled. This is mom and dad over here. 1, 2, 3, 4, 5. Well, now it has a total of 7. They left 7. They left 2 of the kids out. But anyway, these are the ones that are listed in the chart. There we go. So these are separated. This one is 71 seconds of an arc across, very visible in our scope, but it's not a true double. The 3.4 seconds, that's resolvable with our small scopes. 1.1 second, that's going to be a challenge. It is a binary star. Alcyone is actually a triple. And they're wide separations, over a minute of an arc across. This one is a physical pair. It's a binary star. It's
wide.
Yeah, it's very wide. This one is very challenging. This is about the limit. Actually, from my perspective, down here, 3.3, that's the minimum that you can resolve with typical seeing in almost any scope. The air around here just blurs things to about 3 seconds. But
magnitude 3.3, is that what you're saying? Magnitude?
No, it's the separation of the components.
Yeah,
Oh,
the separation of arc. So
That's
you
what we're
can go
talking.
to the Pleiades, and these are the things that are identified in that chart. So look at them. You probably won't be interfered with by the nebulosity. This shows HD 23463.
That was S437. So,
Oh, this
yeah.
physical pair. Yeah, okay. I can't talk and work my brain at the same time. So a lifetime liability. This is Alcyone at 76x. This is S437 at 218 power. So this is separating them quite a bit. That's a very close pair.
Wow.
And this is a picture of the entire cluster taken from Argentina with a handheld iPhone. So
Handheld iPhone?
yeah, handheld iPhone.
Where is it?
The iPhone, this is the picture taken by the iPhone.
Of the Pleiades?
Of the Pleiades. See, the Pleiades are right there.
In the middle.
Is this washed out?
It's a little washed out.
I can sort of see it.
Okay.
I've spent my whole life looking at that naked eye. I always thought it was a Little Dipper. All I could see was
Everybody.
Yeah, that's what it looks like.
Yeah. Everybody does.
there is another Little Dipper somewhere up there, isn't there?
Well, there is the real Little Dipper, yeah, which is Ursa Minor, the little bear.
Yeah, right.
In Orion, people mistake Orion as a dipper too.
Yeah.
Do they really?
Yeah.
So is this better for washed out?
That's better, yes.
Yeah, that's better.
I had to change out of this for the other one because it wouldn't let me advance.
Yeah.
Scattering of stars, that's all part of the cluster.
That is the associate, the star cluster.
I'll be damned. Above some trees in Argentina.
Yeah.
Where that dreaded meteorite came from.
Yeah.
So here is the little dog, Canis Minor. The outline of the dog is a very linear dog.
It's a dachshund.
Dachshund, right. Procyon and Beta. Now this is Luton's star. Luton's star is not visible to the naked eyes. Matter of fact, the most common star in the sky are these red dwarfs. And you can't see any of them naked eye. And this is one that you can pick up with small scopes. And it's a good star hopping exercise. Here's this little triangle of magnitude 7, 8.8, and 7.8 magnitude stars. So you're going to need something like a 4 to 6 inch telescope at least to see these. And here's those same stars again. And this is the star you're looking for. But this will give you access to this smaller 9.1 star pattern. And these little faint stars, 13.1 and 13.2, this is the theoretical limit for a 6-inch telescope under perfect skies. So you're going to need about a 10-inch to actually see these stars well.
Oh.
This
one's flipped relative to the previous one.
Yes, that's right. This is the field of view here is 1 degree apart. So this is a typical telescope that we have with a 25 millimeter or 1-inch eyepiece in it.
Oh.
And this is true field of view, not the apparent field of view. With some of these TeleView and other brand names, you can get 100-degree apparent field of view, but it's still only 1 degree field of view.
Well, you lost me on that one. I don't know what you just said.
Okay, never mind.
That's all right. Don't even try. But it's fascinating stuff. Do most of the stars we see at night, the big ones, are they in our little Orion spur, or are any of them over in the big arm of the galaxy? They're all
over the place.
Depending on how bright they are. Sirius is the brightest star, and it's bright because it's close, not because it's really bright.
But I mean, when you see a picture of a galaxy or denoted, a diagram, it looks like there's far more stars inside the arms that are twirling around pinwheel, than in between.
Yes.
So why wouldn't we see that like we see the interior of the galaxy across the sky? You don't know what I'm saying? Am I making sense?
It's a selection effect, Ron. We see bright stars, and they can be at various distances.
But we're in between arms, are we not? Our little solar system?
Depending on who defines the arms, yeah.
Well, it's been named. It's called the Orion Spur.
Yeah, according to some people. To other people, it's the Orion arm.
Oh, part of an arm then. Okay. I'd rather be in an arm than a spur. I'm sorry. Fascinating.
Okay. Well, this is that fainter little line right here, and the star right there are shown here and here. And these are the positions of Luyten's star in 2024, 2039, and 2054. It's one of the fastest moving stars in the sky.
That's what I was wondering. That's the star isn't there a nickname for that?
No, you're thinking of Piazzi's flying star.
The flying star, yeah. So it's a different one. Okay.
Or Barnard's star.
Yeah, Barnard's star. That's the first one I ever heard about that moved fast.
Yeah.
So really? This one is flying under the radar. So this is the
Wow.
This is the a diagram that compares Luyten's star to our sun.
Oh, it's fairly big.
Yeah. So this is red dwarf. This is the most common type of star.
Red dwarfs.
Yeah.
They're just above brown dwarf. Brown dwarfs aren't lit, right?
Right.
Brown dwarfs
are lit a little bit early.
Yeah.
Brown dwarfs don't glow? There's no fusion going on anywhere, not even on the surface or in the middle?
They had fusion early in their lives, but they've used up the deuterium, which is what they can fuse, and they're not fusing anymore, but they're definitely radiating in infrared.
You're talking a brown dwarf. They haven't collapsed like the big sucker.
No, and they won't collapse.
Yeah, they won't collapse, but become a Jupiter. They become a large Jupiter.
Yeah.
Got it. Oh, there's a record.
So this, So this is Luyten's star also has 2 exoplanets. This is Luyten's star here, and it's GJ273 is the star. GJ273b is the first planet discovered, and GJ and that's this one, GJ273C, this one is the second one discovered. And this one is a disk around the star.
Like an asteroid belt.
Yeah, like an asteroid belt. And this is
Interesting.
the orbit of Mercury. So our sun would be here. So both the planets and the asteroid belt at Luton star are inside the orbit of Mercury.
Oh, wow.
What are the chances of somebody living on those little suckers?
Pretty low.
Yeah.
Pretty low. Drake equation doesn't apply to these guys, huh?
Unless we're made of like asbestos, you know.
Well, no, this is a red dwarf star, so the habitable zone goes much closer to it.
Yes.
Oh, okay, okay.
And it turns out these planets are in the habitable zone.
Are they? But they get nothing
As I
but
recall.
sunrises and sunsets, don't they?
They what?
They get red sunsets and everything's red during the day, right? There.
To our eyes, that
You
would
can't tell that.
depending how bright it is.
On Mars, the sky during the day looks red and the sunsets look blue. So it's exactly the opposite of what we see on Earth.
You know, what's fascinating to me is it has like an asteroid belt like we do.
Well, that's part of the formation process.
Yeah.
Initially, you have a belt of stuff like that, and then you form planets.
Right.
So that's going to be a common thing, isn't it?
Yeah.
Oh boy, I never knew that. Okay.
Vega has a huge disk around it, and they keep looking for planets there, but they're not finding it. And the disk is very uniform, and they're trying to figure out how that happens without planets forming in it.
If planets formed in it, it would have gaps in the disk.
Huh. But the same physics principles as Saturn's rings, just on a larger scale, apply.
Yeah, it's called gravity.
Well, I know, but in the asteroid belt, they're not. You can't see them close together like you can in Saturn's rings. They're all lumped together, aren't they? Little ice
You've
balls.
been watching too many Star Wars movies.
Yeah, I have. You're right.
The
I hear
asteroids
explosions in space.
things are not that close. Like you see the spaceships dodging and not missing. Nothing's
Really?
that close. The rings of Saturn in there might be that close, but
Yeah,
I suspect it's not. So because some of our spacecrafts have gone through the rings and were unhurt.
But it's interesting that there's a little variety as far as shape of things. You'll never see squares or cubes naturally, I don't think. There are some advances. There's some six-sided stuff like on the top of Saturn, hexagons. But as a rule, it's always a globe or a ring. Those are the only two shapes we get in mass in the universe, isn't it?
If you squint at them, yes. See, the Earth looks like a sphere to our eyes, but it's actually this wobbled pear-shaped thing.
Yeah, I don't see that, but I'm sure it is.
No, this one we're looking at the moon. These are valleys that are carved from the Schroeder impact crater. This is the crater Schroeder. And this thing here was carved by a spray of high-speed rocks and boulders that went out from this impact. And this one was carved in just a few minutes. It's also, and this one is deeper than the Grand Canyon and much longer. And they were carved by this jet of rock.
Huh.
Okay, we're getting that thing just does not go in order.
But when a rock crashes on the moon, we don't see it come in, do we? There's no way. There's no atmosphere to.
No, they don't leave a tail.
Oh wow!
Yeah.
There's a wider angle view there.
Yeah, this is straight down from a satellite. I forget which one it is, but this one shows the because Schroeder is actually oops. Let's see. Go back.
That's the name of the canyon, Schroeder?
No, that's the name of the crater.
The impact crater here. This is what it looks like from Earth, I think. And this is what it looks like from a straight. Whoops. I keep changing.
Looking straight down. Yeah.
Yeah.
Orbiting. Mm.
And this is from straight down on it. So this is one of the canyons just ripped out here. And this is the really, really deep and long one. And these were just, what is it? The statistics the dynamics figured out from that are very impressive.
Hmm.
Let's see. Where are
Deeper
we?
than our Grand Canyon.
Yeah.
Well, let's land there. That sounds like a fun trip.
It looks like something that hit that. It looks like it rolled at the same time that it scooped it out. It looks like a string of BBs there.
What you mean, like this?
Yeah.
Yeah.
And you can just see the little tiny, it'd be like if you're drilling on a piece of wood and you're drilling successive holes next to each other.
Mm-hmm. So the debris from the collision, the debris flew out from the impact at speeds between 2,100 and 2,800 miles per hour.
Hmm.
So that is a bullet from a 9mm gun comes out at about 1,300 miles per hour. So it's at least double that.
Hmm. Man.
So that was
So the
quite
rock
a
came,
forceful impact.
so the meteor came in from the lower right.
No, in this picture, the meteor came in straight down.
Oh,
And then
okay.
it's exploded and rock shot out this way. Oh, you can't see my hand.
Yeah.
So this one, it came down and the rock shot out this way and it shot out this way.
Unless the angle is very, very shallow, the craters end up being circular just because everything gets vaporized and it's so energetic.
Yeah.
So does it plow through the soil or whatever that's called, the surface? Or does it bounce?
No, this is where debris from the explosion got thrown along those radial angles.
At that speed, huh?
Yeah. That's shrapnel.
The crater itself is that big circle on the lower right.
This. Yeah.
I'll be damned. It seems to be more recent than some of the other craters,
Okay.
right?
So this is a profile of our Grand Canyon in Arizona, 1.8 kilometers deep. This
Wow.
is one of those two, Valles Plank, and it is 2.6 kilometers deep. Of course, its depth is probably greater because its gravity is less.
Made me wonder, if an astronaut on the moon were to fall over a cliff, would he bounce and live?
It depends on how tall the cliff was
Yeah.
and what the shape of what he landed on was.
Avoid the sharp rocks.
Yeah. He would accelerate to life terminal speeds slower, but he would eventually get there.
Well, those doubters like to think that they're out there on trampolines in the backyard of a NASA facility, bouncing across the moon's surface. Here we go.
Now, from Mars, this is a vessel, a container. This is a small rock that they picked up from, I think it was Perseverance. Yeah, Perseverance. It's believed to be a sample of one of the oldest deposits on Mars. There's no analysis of it yet. It's still on Mars, and we're trying to figure out how to work the budget to get it back here to Earth. Basically the projects to bring it back have been canceled because the projections for funding the project rose to over $11 billion. And the sample timeline was extended to no earlier than 2040. However, China is aiming to launch its own Mars sample return mission in 2028 and have samples back on Earth by 2031.
Well, can I ask a question about that?
Yes.
Do we send a totally new probe or device or rover to land and get it, or is there something there that'll come back like the lunar?
There's no plans currently. There's proposals and hypotheses. So
One of the proposed ways, Ron, one of the proposed ways was there was another rover that would go and collect the stuff that was left behind, bring it to its landing spot where there would be a rocket it would load that would shoot it up into orbit around Mars, and then another orbiter would come and grab that and bring it back. and that's why it got so expensive. And now
Okay,
they're
Jerry.
looking at now the one that I think caused this to be canceled, Jerry, is your godson's helicopter, because they said, "Whoa, wait a minute! If we have a helicopter that can go grab these samples, we can get them a lot quicker and bring them back to a home base and then shoot them home."
Yeah.
But the Ingenuity helicopter wasn't designed to do that.
No, they
But
just wanted to see if a helicopter would even work.
Yeah, that was an engineering experiment.
Well,
So
does-
you will hear more about that point when Martin gives his talk.
Dr. Kakin is our guest speaker,
Dr.
July
Kakin.
11th, middle of the summer. Did he work with another guy that was in charge of the rover?
Oh yeah, that's a team. These teams are not stovepiped that much.
Okay, well, we definitely are going to shower him with questions that night. I got one, how in the world do you joystick something
You
that's
don't.
30 minutes away?
You don't, Ron. You don't. You pre-plan the mission and you tell it where you want it to go.
All right,
Yeah.
but are you using a joystick that sort
No,
of traces
no.
where you want it to go? You just program it in. That's all he
Yeah.
did.
The
Yeah.
time delay is way too long.
Well, I know that, but okay. It's going to be a great night.
Yeah,
And what star is this?
this is Polaris photographed from Paris or from France. I don't know that it's from Paris.
With four
This-
spikes.
Yeah,
Hmm.
it's a nice picture. And you don't have to track very much on it. So it's just it's going a little circle about 1 degree in diameter, centered somewhere, close enough for navigation. The telescopes at Mount Wilson were put together into an interferometer, and it was or not an interferometer. They were
Yeah. It's an
aperture
interferometer.
shaped. Yeah, but they were acting like a very large resolution or a very large diameter telescope. And you can squint at this, and this is an actual image of the star Polaris. Polaris is a double star. It's a Cepheid variable, and it's our
It'll be
navigation
replaced
blade.
It's going to be replaced in
Oh,
a
wait.
few 100 years.
And it's a
I
double
suppose.
star.
How
So
long is it
this-
going to be our North Star? Isn't it due for replacement within a few centuries or?
Yeah, it'll be our whole star in 25,000 years from now again. In the
Oh,
meantime,
wow.
Vega will be it for a while, and a number of other stars will be close to it. And this is a picture taken by the Hubble Space Telescope, and it shows Polaris and its companion star right there.
Companion, wow. And the change is due to us or it?
Us.
Moving?
No, that's the wobble of the Earth's axis.
Okay, we change, but
Yeah.
then,
Yeah.
okay, got it. Interesting. Well, did you cover it all there? Let's see, the
Yeah,
Red Dwarf,
Was
Perseverance, I
that
guess.
was that picture you had of Polaris, the first one?
About that interferometer picture is that you're actually seeing star spots.
yeah.
The first picture you had of Polaris, was that the companion that you had on
No.
there? That one to the left? No,
That one to the
No,
left
no.
is the one you see when you're polar aligning,
Yeah.
the one
This
to
but
the
it's
left.
not the companion.
Oh, it's not.
No, the companion is so close that it takes high magnification with Hubble to see the
Oh.
companion.
Oh, that I didn't know. So that's just the the double star that we see up there.
Yeah.
Okay.
Yeah. You see both of them. You can't separate them with your telescope.
No, but I see the other one from that first picture.
Yeah.
Yeah.
But technically, it's not exactly in the north. It's a little off by what, half a degree or
Yes.
something?
0.43.
Is there a
like that.
spot there that science puts that is exactly above our axis?
Yes.
There is one.
North celestial pole.
Well, gentlemen, are we done? Because I could still eat up tons of this stuff. Man, I feel like it's an ongoing Broida Hall physics class I'm taking, and it's always good to be with you. And we had a grand time Friday night, and tomorrow night is what, Telescope Tuesday out at well, it's
No.
on the
Oh, that got rained out. Tomorrow night is Monte Vista School Science Night.
okay, but I was thinking of Camino Real. The isn't that
Right, that
telescope?
got rained out. That was last week.
Okay.
Oh, that was last week. But so
Oh,
it's this Friday we're at Westmont? Or next Friday?
No, Friday the 21st.
Friday first. All right. Well, we're
It's
out there.
First
Chuck, I
Tuesday
meant
is
to
in
ask you,
Real,
did those two ladies talk to you about
Agora Hills.
yeah, in Agora Hills?
Yeah, I sicked them on VCAS, Ventura County Astronomical
I,
Society.
I did too.
Yeah. And I
Yeah.
also gave them just the Night Sky Network page because there are some other clubs that might do that.
Yeah.
You know,
Okay.
I have to contact Andre. I think he's under the impression this Friday was Westmont, and I know the calendar was a little bit off, and I kind of spaced on that, and I didn't tell him. So
Okay.
we'll still try for that.
Well, good. Have a good day. See you next
Okay,
week.
let's